these quite quickly. You remember, what I would like you to have in front of you is that formula sheet that I gave you, okay? So you need to find that formula sheet and have that out. You get given this exact sheet in the test. On Thursday's test.
Okay.
Do you give that? Pardon?
Do we have to give that?
No, you get given this at the end of year test too. Okay?
Wait, do we have to give that back to you last lesson?
You weren't here last lesson, that's why I just
Well,
gave
the
you
other
it.
lesson.
So, this...
Oh, I don't have that.
Did you read there? No, she's not. Oh, yeah, it's right on the front there. Well, it was on the test one.
Oh,
Okay, right, so, what shape is this first one?
Georgia.
Yeah?
This is the area times 5 base times height, and then divide by 2.
Good. Base times height divided by 2. Remember, your base and your height have to meet at 90 degrees in order for that to work. Okay? So if you'd known this bottom number here and this one of these slopes, you wouldn't have been able to use that formula. But because you know those two measurements meet at 90 degrees, you do base times height, divided by 2. So 20 divided by 2 is 10. I'd say I'm going to rush through this. Now, what shape is this next one here? Somewhat different. It's the same thing all the time.
Parallel.
No, it's not a parallelogram.
No.
Antigua, what shape is it? The Americans have trapezoid, yeah, trapezium. Okay. Now on the front sheet, this is where I'm going to guide you to the front sheet. I'm not going to be able to do that at the exam, in the test or the exam, but I'm guiding you now. So you're going to look at the front sheet, and it has the formula for the area of a trapezium. Yes. Some of you spotted the formula, but you didn't read it carefully, so you incorrectly inputted it. So the formula is a half a plus b multiplied by h. Now, a plus b, where are the a and b measurements, Georgie? The top and the bottom. Now, it's not always going to be the top and the bottom, because if it had been flipped on its side, it would have been the two side ones. Essentially, it's the parallel sides. Okay, so your a and your b are your parallel sides. Sarah?
So I saw this on a piece of paper and I looked, I did it on my calculator, I did a half times 12.8 times, plus 12.
Yes, sweetheart, you missed brackets, you didn't put brackets in, and they make all the difference. Okay?
I put the brackets on the two on this calculator, or is there like a special button?
No, I don't believe you would have used brackets. You didn't write brackets in your working sheet, and I think that's where you went wrong.
Oh,
So we need to practice that then on the calculator. As I say, I'm trying to go quickly so that then we can get this all done now, and then the next 2 lessons, I think we still have 2 more lessons before the test that we can actually do small practice. Do we have just one more? Okay, so it's just one more. Right, so we've got a half multiplied by 11.2 plus 12.8 bracket multiplied by 6. So if you put it into a calculator just like that, you will get the correct answer. I forget what it is, but it doesn't really matter. Okay, again, you can watch this on a video later. It may be better off to absorb it now rather than stress about copying everything down. So, what shape is this next one, Maya? Triangle. What's my base and what's my height? Good girl. 9 multiplied by 19 divided by 2. Again, doesn't matter what the answers are. Fastica, what shape is the next one? This one is a parallelogram. Good. How do you find the area of parallelogram, Madison? Do you remember? Have a guess. What might you do to find the area of this? You're in the test, you can't remember. What's your gut instinct you're going to have a go at? What shape does it look similar to? I think you mean rectangle, yes? So how would you find the area if it was a rectangle? Can't remember how to find the area of a rectangle? Alright, yes, where? Multiply the sides together. So you would have base times height or length times width to find the area of a rectangle. Super, super important that you learn how to find the area of a rectangle. Okay, Madison? So this one, whilst it's a wonky one, because they have given us the measurements that are perpendicular to each other, you do literally do 10 multiplied by 12. This one is not divided by 2 because it is a parallelogram, not a triangle.
Are all these answers power?
Now, all of our units for these ones are units squared. So this would be centimeters squared, this would be meters squared, because these are all areas. Remember, areas have a unit squared. Okay? It is not the number squared, it's the unit that's squared. Okay? So their area ones always have square units. Because that's the sheet you're going to be given for the next few tests. Excuse me, it does change slightly now for GCSE in that you don't get given the area of a circle and the perimeter of the circumference of the circle, but we want to give you that one because we don't think you need to learn it just yet. Okay? But you get given those in all your tests and everything that you do. And so we've learned about Pythagoras' theorem, so I want you to recognise that it's on there, so you'll get that here in the exam. Now, these bold and underlined volume now. Okay, so we're finding volume. So with regard to your units question, Maya, these are all going to be meters cubed or centimeters cubed. Our units are all cubed. Okay, so the volume, they're cubed. This shape here is a cuboid. Okay, so these marks here, what do these marks here tell us about those measurements? Maya?
It means all the measurements on the scale.
Good, so I could label that 2 and that 2 and that 2 if I wanted to. And how do we find the volume of a cuboid, Sarah?
You do length times width times height.
Good. Essentially, a good thing, remember when I taught it to you, is if you place your finger on one of the vertices, you'll multiply the 3 measurements that meet at that point. So for a cuboid, for this one, it would be 6 multiplied by 2 multiplied by another 2. Now, sometimes some people just saw 1 6 and 1 2, so just multiply those together. But you've got to be careful that they've labelled them to give you enough information. So you need to know to multiply from 3 fourths.
Why would you only do 2 on 2 2s?
Because the other one is a 6. So this is 6, 2, and 2.
Oh.
So it's the 3 measurements that meet at that point. Okay, this next one is a cube, not a cuboid. Cubes all have the same measurements, okay? They're all equal to each other. So I could label all my measurements here with a 3. Gets a bit confusing, that's why we don't bother doing it normally. Same principle though, if we choose this vertex, finding the 3 measurements that meet at that vertex, what would we have there? See that? 3 multiplied by 3 multiplied by 3. Perfect. And as I said, the actual number itself I'm not fussed about. Now, these ones, lots of people left. Do you know what? These are the easier ones. These are way easier because they've told you this part here. Now, on your formula sheet, it's got a prism, yes? It says volume of a prism. Who can read to me what it says? How to find the volume of a prism? Georgie?
Wait, where is it? Area of cross-section times.
Okay, so the area of the cross-section, excuse me, multiplied by the length. Well, it says the area of the end. That's that shaded bit.
That's the cross.
That would be the cross-section in this case, yes. Multiplied by the length. Well, what do you think is their measurement for the length? That's this one here, yes? So you're doing 28 multiplied by 9. How super straightforward is that, yes? So they did some of the hard work for you because what they did up here was find the area of the cross section first and then multiply by the length. Okay, but they've already done that for you here. And so Sarah, what would I do for this next one?
You would do see what 17 goes into 30.
Not they would have too hard, no? Why do you want to divide it? Remember we said the area of the volume of the prism is the area of the cross section multiplied by the length. What's the area of the cross section?
17.
The area of the cross section.
30 centimeters.
You have it in front of you as well, don't you? Oh no, you don't. Okay. 30, and then what's our length? 17. So what calculation are we going to do?
17 times 30.
Good go. I'm going to do 30 multiplied by 17, just so I can keep with the order of the formula. Okay, so it's the area of the cross section multiplied by the length. Okay, any question?
Yeah, I think what threw me off was the squared after the meters.
Because we know that all areas are meters squared. Yes?
So the square doesn't really matter.
No, because what happens is you've got 28 meters squared multiplied by 9 meters. Well, what happens when we have a meter squared multiplied by a meter? It becomes a meter cubed, doesn't it? So it's that's where our units come from. Yeah? Right, okay, so we're still trying to find volume, but this time we need to work a little bit harder because we need to establish what the area of the cross section is. So first of all, we need to know what shape is it. What shape is our cross section? It's not true. Yes, right? Pardon? Triangle. Yes? Yes. So it's a triangle. What's our cross section is a triangle. We talked about how to find the area of a triangle. How to find the area of a triangle, Madison? Good. So what's my base and what's my height? Perfect. So that's my area of my cross section. Yes? Then what do I do with that number, Jane?
You times it by 12.
Multiply by 12. Oh, sure. Done. Now, this one here. Ooh, it's a cone. Lord above, it's a cone. What on earth are we going to do? It's a cone. What are we going to do, Georgie?
So it says you 1/3 and you times it by 5 and then 12 squared.
Well, hang on, so pi r squared h. Now, what did you said it really quietly, but it was the most important thing that you said. You said on the formula sheet. Yes? So this is where you think, I don't remember how to find the volume of the cone. Handily, you don't have to remember how to find the volume of the cone. It's written there for you, okay? So you just need to establish what the values are. Well, 1/3 is 1/3. Okay, that's not going to change. Does pi ever change? No. So we're going to have pi. Remember, these are all being multiplied together. Now, r. What does r represent? What does r represent, Kaya?
The radius.
Good, the radius. The radius of the circle of the base, yes? So what is my radius of my base? Be careful here. 12. Why is it 12, Maya?
Because at the bottom it gives you the diameter.
Good girl.
And then you just divide it.
Good. Because they told us the whole measurement here is 24, we know that the radius is half of that, so we know ours is 12. But don't forget that that number's squared, okay? And then in our case, our h, our value for h would be what, Maya? Oh, Maya? Got a board here. 20. So we multiply by 20. Try that in our calcs, and we get a brilliant answer. Okay? Zooming. Right, so another.
Meter cubed, right?
All said all cubed.
Oh,
Yes.
how many decimal points do you guys have?
Go for 3 significant figures or whatever sensible. Choose something sensible. Don't write too many digits.
Sometimes I do 2 decimal points. Sometimes
Do whatever you want to do unless it tells you otherwise. Alright, our cross section. What shape is our cross section here, Sarah Laura?
it's a prism.
It is a prism. What's the shape of our cross section?
Oh,
What shape is it?
it's a line.
Shape. Our cross section can't be a line, sweetheart. It has to be a shape.
Triangle.
Where do you see a triangle there, hon? From this shape here? There's no triangles there, sweetheart. So we're looking for this shape here. Okay, cuboid is a 3D solid. It's not a shape. What shape is that?
Does it start with an R?
No.
What's it?
It's one of those. You need to know how to find the area of it. You need to know the name of it. Begins with a P.
Pentagon?
No, sweetheart, it's not a pentagon. It's a parallelogram. So we found out, we talked about areas of parallelograms already. How do we find the area of a parallelogram? Sarah, do you remember that?
1/2. And then
That was, you're thinking about the trapezium, sweetheart. Look at the one that looks a bit like this. Did you draw the pictures of the shapes?
yeah, go on.
Okay, so which one looks a bit like this? Casilla.
Maybe the one that has
Yeah, that's exactly the one we're talking about. How did we find the area of that? Good go. Oh, no, not 12 times 6. Because look at the shape that we're looking for is the blue one actually shaded.
8 times 12.
Good go. 8 times 12. Are you all happy with that?
Yeah. It's a 6.
Now, my area of this one would be 8 multiplied by 12 because that's my base and my perpendicular height. Okay? Now once we've got that, we would then multiply that by the distance between them, which is then the 6. So the 6 comes into play, but I'm just keeping in consistency with what we're doing in that we find the area of the end face, multiply by the length between them. Yeah. Alright, next one. What shape is this one, Jade? What kind of solid is this? I apologize. What solid is it? It's with a C.
I want to say keyboard, but it's not keyboard. It's a cylinder.
It's a cylinder. Now, anyone with their sheets in front of them? Pasika, how do you find the volume of a cylinder?
Use pi r squared.
Pi r squared h. Okay, so that's what we get given. We just need to make sure we're sticking in the correct numbers. So, as we said before, does pi ever change?
No.
Now, what does r represent?
And radius, and I
Yep.
think 0.7.
Good go. The radius in this case is 0.7 because, again, they told us about the diameter, so we had to halve that. So we're doing 1 multiplied by 0.7 squared, multiplied by h. What's our h in this case, Madison? Good go, 2.6. Chuck all those numbers in, get a brilliant answer. Okay, we are steaming through. This one was well done. I think for some reason you got all excited and knew what you were doing when it came to this one, even if you had forgotten for some of the others. So this is a box of matches. What is a cuboid? How to find the volume of a cuboid? You just multiply the 3. Again, the 3 measurements that meet at a vertex. So it's 37 multiplied by 16 multiplied by 50. Chuck it in, and this is millimeters cubed. Now, these ones are a little bit different. Okay? So these ones are a bit harder. These are the type of thing that might be in the application or extension section. Yes? So it's the extension stuff. Excuse me. It says express the volume in terms of S, which means that we don't have a numerical answer. So there is no magic answer here. We are going to have the letter X in our working. So what we do is we say, okay, what would we do with this? We find the volume of a cylinder. Remember, the volume of a cylinder was pi r squared h. That's what we get. That's what we get given. So does the pi ever change? No. What's our value for r though doing this one? This is a trickier one. Georgie? Not x cubed, we don't know. Not x squared. What's the reason like this? I just want to know the value of r. Just the value of r. Sarah?
It is X.
No. Because remember, look at x. X goes from one side to the other. Pasika? 0.5x. Good go. So the value of r is 0.5x or x over 2. Both of these are the same. Okay?
Yeah, I was going to say x.
Okay? So x divided by 2 is the same as a half of x. Okay? Right? 0.5 is a half.
X with the X.
So yes, you must have the x. Okay? Hello? Listen to what I'm saying. Listen to what I said. You're going to write your answer in terms of x. So do not panic. So we've got x over 2. I'm going to keep with this one just because it's a little bit easier than having 0.5. But for Zika, it was totally correct. So we multiply by that by x over 2 squared, because remember our r has to be squared. And then what's our h? Sarah?
H is 3X.
Good go, 3x. Now, you should really be putting brackets in there. Now, I would give that to you as a mark. Okay, I would give that to you. Now, it's better if we simplify it though. So our pi stays as it is. X over 2 squared. Now, remember, this square affects both of these two here. Okay, so that now becomes x squared over 4, because x squared is x squared, and 2 squared is 4. Okay? And then we're multiplying that by 3x. And then we've got an x squared here, multiplied by an x. What happens when we've got x squared multiplied by another x? It becomes x cubed. Good go. So we've got pi multiplied by 3 multiplied by x cubed over 4. Now, any order of those things here is brilliant. Okay? Now, it is complicated. Okay? I'm not denying that. But you have the skills to do that, yes? You were given the formula. You know that the radius is half of this. So it's just tricky. The only complicated or tricky thing is that you're using letters instead of numbers as you did before. Okay? And as your gut instinct always is going to be to chuck it in a calculator, but sometimes you can't. You just have to leave it the letters.
So we'll still have marks if you put the first one.
I would give you the full marks if you left like that. I would. Okay? Perhaps if we were,
What do you know for graphics?
then I might be harsh on you because you need to know that both of these two things are squared. Okay, so if you just put x squared over 2, that would be wrong.
Does the 3x have to be in brackets?
No, I would accept that not being, but this one would have to be. Alright, so then we go, this one's actually a bit easier. If we put this one first, it may be a bit easier. Again, how do we find the volume of a cuboid? What do we do with those measurements? You shouldn't need to look. How do we find the volume of a cuboid?
Oh, it's all 3 of them multiplied by
Yeah, so tell me what to write.
Okay, so it'll be 2x multiplied by x multiplied by 3x.
Nice, okay? Now, we've done things like this by simplifying these kinds of things. They're being multiplied together, so I can deal with my 2 and my 3. What's 2 multiplied by 3? 6. And then I've got x multiplied by another x multiplied by another x. X cubed. Done. How simple was that one, hey? That was nice. That was a really nice one. Alright, here we've got a code. Uh-oh, we need to use our formula again. So we need to find our formula. It's 1/3 pi r squared h. So this is the formula we get given. So does the 1/3 change? No. Does pi change? No. What's our value for r? So what expression can we use for r? Good go, x. This measurement here is the diameter, and that's 2 lots of the radius. So our radius is x. So we're going to do x squared, and then what's our x? 3x multiplied by 3x.
That it?
No, you got to simplify.
Okay, now if we can simplify it, we can. Now look, we've got 1/3 multiplied by 3. 1/3 multiplied by, which is 3/3, which is 1 whole one, yes?
4x.
No. So this is 3/3, that's just 1. 3/3. Oh, maybe I'll put it in there. 3/3 multiplied by pi multiplied by x. So we've got x squared multiplied by x, which is x cubed. Now what's 3 over 3? 1. So do we need to write that? No, so it's just going to be pi x cubed.
Right, so why is there? So, okay.
So this was from the formula. The 1/3 multiplied by 3. Remember, 1/3 multiplied by 3 whole ones is 3 over 1. Rules of multiplying fractions, top times top, bottom times bottom. Yeah? If you need to, you can chuck that in your calculator as well. Alright. We're flying through these. Each month. Okay, here's the key here, but some people made a mistake here. Each month, the rectangular swimming pool, 6 by 5 by 2, costs 50 cents per cubic meter of water to maintain. How much will it cost to maintain it for 1 year. So let's find our monthly cost. So our monthly cost, we need to first of all find our volume of our pool. How do we find the volume of the pool, Manson? So tell me what to do. Google, because it's a cuboid, yes? So 6 multiplied by 5 multiplied by 2 gives us 60 meters cubed. Okay? It says it costs 50 cents per cubic meter. Well, how many cubic meters do we have?
60.
60. So how are we going to find the cost per month?
Times 5.
60 multiplied by
300.
50. 0.50.
0.50, yes? Dollars. Where are you getting your numbers from, Estelle?
Actually, 5 is 0.
Okay, so you understand how we got that, yes? So we get 30, I think, don't we?
Yeah.
Okay, so $30. So that's our monthly cost. So our year is going to be 30 multiplied by 12, which is $360. Yes?
Oh, yes.
Yes, because it's for a year. Okay? Right, we're back to areas. Okay, some people were like, oh, seriously, area? It's supposed to be a volume test. But you need to know how to find the volume. In order to find the volume, you need to know the area. So that's why we're bringing them in. Right, so we're finding the shaded area. So these are those ones, remember, that you have to think carefully about what is happening here. Describe to me the circled shape, the shaded area, sorry. Describe to me how we would find that shaded area, just using words, no numbers. You don't need to tell me numbers. Remember, you don't need numbers. Just explain to me how to find the shaded bit. Explain to, I'm a little Martian. Tell me how I would find this shaded bit. Zika, you were considering it. How would I find the shaded part? In like basic language. Not even getting that complicated. Okay, I'm gonna explain in very basic language. The shaded part is the area of the big circle, subtract the area of the small circle. Okay? So to find the shaded part is the area of the big circle, subtract the area of the small circle. Now, do you all understand that? Why only kind of?
No, I don't know why.
You don't really? Genuinely?
So you just do it because.
So if you want to find the area of the area of the shaded bit. One second. Oh, what on earth is that? Oh, here we go. Alright, okay. Now, my trauma dilemma, my initial question was literally just how do you do it? I wasn't asking for numbers. The important thing is that you appreciate to find the shaded area. It would be the area of the big circle, subtract the area of the small circle. Yes? You all appreciate that now? Yes? That's how you make that shape, yes? You have a big circle, you cut out a hole. So then we say, okay, well, how do we find the area of the circle? Well, the area of the circle is pi r squared. That's from the formula sheet. So for our big circle, subtract small circle. Area of the big circle. What's my radius for my big circle? Georgie?
5.
Good girl. My radius is 5. Okay, so I would have pi multiplied by 5 squared. What's my radius for my small circle, Kaya?
Oh. 2.
Good girl. So that's pi multiplied by 2 squared. Chuck that in your calc, you get an answer. Easy, lemon squeezy. Okay, next one.
Wait, I'm really not.
Okay, sweetheart, I can't. Right, next one here. It's a little bit trickier here. Because it looks like there's not enough information. We did talk about this briefly on Friday. But there is enough information. Do you remember I said to you, if this was my radius, I would know my diameter goes all the way across, yes? And I know that my diameter is the same as the length of each side of the square. So that means that my square, each of them are 24, yes? Do you see that? So if my radius is 12, and I know that the circle goes from one side of the square to the other, it means that the length must be 24. In a similar description way, how would you describe how to find the shaded area? In a description way similar to the one I did here. Georgie? Description.
Radius is half of the.
No, description how to find the shaded part. Jay?
You multiply.
No, description of, like I said here, the area of the big recording. I am. The area of the big circle subtract the area of the small circle.
The area
Of the square. Square. Subtract the area of the square. Okay, but you know it's that way around, yeah?
Yeah, I said that.
Okay, good help, Kaya. Well done. So the area of the square subtract the area of the circle. So area of the square, we know that each side is 24, so that's going to be 24 squared. Subtract the area of the circle. Well, circle was pi r squared. What's the value of r? 12. 12, so we're going to do pi multiplied by 12 squared. Again, chuck it in your calc, you'll get the answer. No, we're moving on. Go. Right, so we're going into standard form numbers now. Okay, some of you had left a lot of these blank, which is a bit disappointing. Right, Sarah, what's this one here?
So since it's a negative, you put those before the gate.
Good. So you put a few zeros in.
Yeah, as many as you want. And then what you do is go back 3. So 1, 2, 3, and then that's what it was. So 0.008.
Lovely, thank you. That's a great explanation. So it's a negative power, as Sarah said. So we know it's a small number, so you put the zeros on the left. If you had put 0.0082, that's totally fine. You must make sure there's only one decimal point here, though, so don't put it in between the 8 and the 2 still. Okay? Remember, there was that sneaky trick I told you that if it was -3, then there was going to be one less zero here, but that doesn't matter as long as you're working them out properly. 5.65 times 10 to the 9 gives you 565 and 7 zeros. Okay? It's a similar principle, but this time the zeros are all on the right, and you're jumping your decimal point 9 places to the right this time. 176. Lots of zeros for standard form, so this will be 1.76 multiplied by 10 to the 10 to the power 9. And the next one would be 6.02 multiplied by 10. What do I know about my power? It's going to be negative, so that's -6. Okay? What did I do? What did I tell you when it came to calculate questions? What do you have available to you? A calculator. Alright, so to stick this in our calculator, remember you use a special power button so we can type 4. Oh, this isn't going to work. Okay, so we type 4. Remember, girls, we use this button at the bottom and we're going to type -6. Okay, so that's our first number put in. Press multiply. 7. Use that special button again. This time it's -6. Oh, -6 again. Press equals, and they tell you the answer in standard form. Okay? Next one. 5. Special button. 7. Multiply by 6. Special button. 4. Again, they've given it to you in standard form. The next one. 1.8. Special button, 19. Divided by this time,
3, special button 9. Okay, they've given it, they write it like this. We need to make sure that we can change that to standard form. Now, yeah, you're just going to have to make sure you know how to do it.
Times 10 times.
Next one is 3, special button negative 16. Divided by 5, special button negative 7. Gives you 6 times 10 to the negative 10. Okay? Say whether or not the numbers are in standard form. So the first one is in standard form. So that's a yes, it is. The next one is not. Why not? Sarah?
Because what happens was it's not below 10, so you have to bring that over.
Well, it is below 10, but it's also below 1. Yeah, so remember, this bit has to be between 1 and 10.
Oh,
Now,
you're going. We need to go
so,
1.
well, hang on. So let me help you out here. Look, now, I'm going to type this in. 0.782 to the power negative 3. Okay? Now, if you press equals and then do that, it changes it to standard form for you. Okay? So if you had forgotten how to do it, you can use that method. All right? So this one was not, no. These 3 all were.
I wrote the answer.
You can just put them in your calculator, yeah, and do how I just did.
Because you meant.
Yeah, you were supposed to. Right, okay, next one. Shh. All right. Now, you've got to be careful here because this is 15,000. You need to know what 15,000 looks like. 15,000 looks like 15 with 3 zeros. So you're going to have 1.5 multiplied by 10. And then you have to decide how many places you've moved your decimal point. So that's 1, 2, 3, 4 places. Okay? 4 million. How many zeros has 4 million got? Maya? 6. Okay, so there's 6 zeros here. So it's going to be 4 multiplied by 10 to the 6. Next one. Speed of light is 3 times 10 to the 8 meters per second. How far would light travel in 100 seconds? Well, you've got here distance equals speed multiplied by time. So we know our time is 100 seconds. This is our speed. So it's a calculator question. 3, special button 8, multiplied by 100. What's the matter? Why is everyone saying wait? So our speed multiplied by our time. It says here distance is speed multiplied by time. Press equals. There's your answer. The next part says the mean distance of the Earth from the Sun is blah blah. How long does it take for light to travel from the Sun to the Earth? Well, how long? Okay, this time it's a time question. Do you know how these triangles work?
So time is distance times time equals distance times speed.
Not times, no. So if you're looking for time, then it's distance over speed. You see how distance is up in the air and speed is underneath? Do you see that? So distance is up here, speed is underneath, so we're going to do some division. Sarah, are you looking? You don't need to be doing your hair right now, sweetheart. So our time is going to be distance divided by speed. Well, they said the distance was this, 1.5 multiplied by 10 to the 11, divided by the speed, which was up above. And we chuck that in our calculator. So we do 1.5 special button 11 divided by 3 special button 8. There we go, 500. Now, what unit do you think that might be if it says time? 500 what?
Minutes.
Look at the rest of the question. What kind of unit do you think it would be? Time. Time. How long? It's in seconds, okay? Because this was in meters and it was per second, okay? So that would be 500 seconds. And the last few questions. This one here, how are you going to do this one? Just tell me how you're going to do it.
Put it in the calculator.
Put it in your calculator. Exactly. Put it in your calculator. 4.78 divided by 3.25. If you get an answer like that, remember, press SD. Now you're going to have to change that to be standard form probably, unless they accept it in that format. Now this last one again, it's probably more one of those extension-y questions because they've written it in a weird way. So they've said here, P take away Q divided by P multiplied by Q. But they've told you what P and Q are here, look. So, you're exactly that, Fasiga. Put it in your calculator. You're going to open up a fraction, because that looks like a fraction. P is this number here, so 4 special button 5. Subtract Q, which is this one, 1.25 special button 4. And then on the bottom, we're going to do those two numbers multiplied. So 4 special button 5 multiplied by 1.25 special button 4. Enter that in. There's our answer. Yep. Okay. Right. So that is that test gone through.